I'm Roland Santos. I work for the Michael Smith Genome Sciences Center. I'm an assistant systems coordinator, which implies that, yes, I am a sysadmin. I'm not a bioinformatician, but I have watched them on television. So let's see. Okay. I've been with the GSC for about 10 years now, and I've watched it grow ever since the has exploded in the mid-2000s. So we're part of the BCCA, and we're aiming to develop and deploy genomics technology in support of life science research. In our case, cancer research. Okay, and with that, let's go into ORCA. Let's see, share ORCA. ORCA. And let me check, is it sharing now? Yes, it is. Okay, so the Genome Sciences Center is part of Compute Canada, part of Westgrid, and this is part of the resources we share out to the rest of the community, and something we came up with about a year or two ago, and now we're sharing it to everyone. So ORCA, Genomics Research Container Architecture. Just a quick outline of what we're going to talk about. It's pretty simple. I might just breeze through the slides, but let me know if you have any questions at the very, very end. So ORCA is made as a platform for bioinformatics analysis. We've always had this problem of validated bioinformatics tools. There's so many tools out there, so many different environments. We wanted to have, a single, you could call it an environment where you can have validated tools that you know are going to work, and they are all compiled the same way with the same libraries and all of that. In addition, we also wanted private and secure environments. So what you would be working on should not be visible from other people using the same platform, which is a little better than your standard Linux, interactive Linux server environment. And it's primarily meant for self-serve analysis. Self-serve as in, you know what you're doing, you know how to use a command line, and you just want to go somewhere and do your analysis. And as I said earlier, this is part of the Advanced Research Computing Platform and Compute Canada node for GSC. Oops, current slide. So we talked about validated bioinformatics tools. So by validated, we mean we include a lot of the libraries, if not all the libraries from Homebrew-Science, over 180 tools, SPAM tools, SAM tools, BWA, FASTQ, pretty much anything you would need from an analysis standpoint. If there are requests for more tools or other tools, we will try to accommodate them. At the same time, there are limits to the size. All of them are pre-installed using Linux Brew. You don't need to even run an install command for most of these tools. You just start using them. And the software is versioned. You can go back to the older versions that have been installed. So that's good in case you want to do, want to go back to an older version of a tool and you want to redo an analysis. We talked about private and secure environments. So connections are by default encrypted. You're using SSH. Every user gets their own private environment. Right now it's implemented using containers, but we are not limiting the ORCA to that kind of concept. So if you find something that's probably more secure and more private, then we'd probably go with that solution. Each container should get their own dedicated storage volume as well. So that's it in a nutshell. And if you need an account, there is someone at the Genome Sciences Center, Diane Miller, who is the primary point of contact for the ORCA project. And she will happily get the account requests and get them created. Okay, let's start with how to connect. I have a Linux server outside of the GSC. Okay, you can just see, one sec. Share that out. So did the slideshow show up for anyone, or didn't show up for some people? Okay. Jana can see. Oh, okay. It's just in the department. Okay. Okay. So I was talking about earlier. Hopefully the slides were showing up while I was talking. Oh, good. All good. Awesome. Okay. Let's go to connecting to ORCA. Once you've obtained your account, let me bring up. Okay. So now we're on an external Linux server, or you could think of it as, you're on your laptop, you're on your command line, and you want to connect to ORCA. It's available outside of the Genome Science Center. You just SSH as your user account at orca-wg.bcgsc.ca, and away you go. What happens in the background here is, as you log in with your normal SSH connection, we do start up your own private container in the background, and you end up inside it. So what happens there is, when you're on the system, you run your processes. That's when you're using your resources. And once you get out, your private container is actually suspended, so it's not taking up any resources on our end. So we're able to support a lot more users, as long as they're, reasonably well distributed. There's a little bit of a delay right now with the connection. I'm not sure how long it takes now, but I do have another one that's up. Why don't we go there and let's continue from there. Okay. All right. We'll go back to the other terminal once you get a connection going through there. But this is what it should look like once you connect. You're just on your command line. I mean, you wanted it to look as the same as logging in onto a Linux server, except that you're shoved off into your private container. Right. As I said, there's a lot of installed software. Let's see, software. Oops. It's a bit of stuff there. And for example, if I want to run BWA, it's right there. This is BWA 712. SAM tools. Double checking the versions of the tools here, because I'm not familiar with a lot of them. So version 120 for SAM tools. Does anyone have any anyone want to find out about the different versions of the tools that they want to use here, and if there's any tools that we're missing? Hi, Jan. Do you know if people can actually speak up, or do they just talk back via group chat? JT.
Yep. people are able to speak, you can, if you have muted yourself, you just need to unmute by clicking the microphone. You'll know you're muted if the microphone is red. And or you can, if you choose, type your questions in the group chat. And I see that there's 2 in there now, one from Sean and one from Philip.
Okay. So Sean, you can get an account right now through the Genome Sciences Center. I had a slide here with the contact information of the project's coordinator for this project. So you need to contact her. Right now we're not connected to the Compute Canada directory, but it's one of the things that we are looking into in the future. You should be able to log in eventually with your CCTV account or whatever Compute Canada account you have. But right now, it's its own directory. And GATK. Okay, so genome analysis toolkit. I'm pretty sure. Use GATK. Did anyone try connecting right now? Actually, anyone have an SSH connection? Just want to see what it looks like. Sorry about that. I went back to the other connection. It timed out.
And there's a question, is this free for Canadian researchers?
Yes. It's free for Canadian researchers. Oh. So Philip, I remember creating your account. It's just be Richmond.
Yep, so if you didn't request to register for an ORCA account before this seminar, we had a deadline. You had to register for one before, I think it was November 24th, and those were the people who have had test accounts created, and you're able to log in today. But if you did not request one of those, then you will not be able to SSH in, as you won't have the login information.
Mm-hmm. Yeah. So far, okay. Free for Canadian researchers. Default allocation of resources. Right now we have a few terabytes allocated in storage for this. And you're free to use most of them. I have had to restart a couple of containers because they ran out of memory. But as I said, I mean, it's on a, you should be able to use up to So for the person who wanted to use GATK, I'm on the terminal right here. You can help me out. Mauricio, yes, Docker is our current container platform. We're using version 1.11 right now. I know 1.12 is out. I don't know if they came out with anything recently, but we are aiming to keep up to pace with their releases. But at the same time, we want to de-emphasize the choice of container platform, because if we find a better suited platform for this, then we will move to that. Right now, the containers, okay, so the question is are you able to share your containers? Right now, the containers are located in the Docker container. So on the ORCA servers themselves, they're local to each one. We have a small swarm of 2 Docker hosts right now. Right now, we don't have the facility, the automatic facility, to actually ship you back your containers, but it's something that we can look at if there's enough requests for it. Right. If a container becomes unresponsive, can you revert back to the previous session or container snapshot? If a container becomes unresponsive, the last known state will be loaded. But off the top of my head, I don't know if we do periodic snapshots. But yeah, so worst case scenario, you go back to the beginning, unfortunately. But your data, if you write it in /home, is actually saved to a separate location, separate volume. So if you're writing there, you can pick up where you left off if your tool can load back like intermediate data. But it's not guaranteed right now. Sean, default resource configuration for each container. Right now it's 1 core, up to 64 gigabytes of RAM. Storage is backed up. It's on a separate network attached storage. It's not local to the container itself. That's good. And keep the questions coming, because access to predefined databases. That's something we've encountered. A lot of the tools have their own databases, and what we found is some of them are pretty large. Some are much larger than the default, than containers can safely hold, so we don't have all the databases. There are some that are multiple gigs in size, and we just had to leave them out for just so you're able to start a container, in a reasonable amount of time. And I don't know what databases we have in here. Plans for a network share to hold these predefined databases. There are no current plans, but we are open to future requests. And yes, that is actually, if we wanted to include them, that would be the way to go. So from how many terabytes of disks per container and any way to expand. So on the back end, we can expand the storage allocations. Right now it's set to, for this demo, we've set it to 4 terabytes. But if there is enough requests and enough demand, we should be able to expand it to, I would say, given enough disk, we can expand almost to the petabyte range if we wanted to, if we had the resources to. But yes, it's using network attached storage in the back end, but we're on top of that, we're not really married to that concept. If we find another storage platform that suits this application well, we will go to it. That's why I want to de-emphasize the technologies that we use, for example. I want to de-emphasize that we're using Docker or that we're using a network attached storage in the background, because what's important is you have a place to store your things, and you have validated bioinformatics tools to run your analyses with. So terabytes of disk per container, right now it's maximum 4 terabytes for the demo, and no default allocation. We are still figuring out what's a sustainable allocation. That's a good question. Next question from Philip. Does it have X Windows capabilities? In terms of to-do, that is actually next on my to-do list. We've had people give us plenty of feedback about X11 forwarding from the Docker containers. So that's next on my to-do list. Yes. So no right now, but it's the next feature that I'm working on. Okay. Comment. You want to share your compute resources? Yes. We do want to let people do that, but right now our main goals, one of our main features is isolation in terms of containers. So we haven't had the chance to work on the sharing containers feature. Okay. Any more questions? How do we process software requests? Okay. I'm going to take this in order. So Philip, how do you process software requests? To get it installed get a piece of software installed in ORCA, we actually go through manual process. We get a request from a person, we put it in an issue tracker, and we update it. At the same time, we also plan to update this on a regular basis. So not only do we get new software installed, we also get new software versions for existing stuff as well. Does that answer your question, Philip? Yes. So Chris, what are the advantages, disadvantages of using ORCA over a Westgrid server directly? So I would say the main advantage here is isolation. And so when you're running your jobs, you're running in your own little isolated container that no one else on the same system can see what you're working on, for example, unless you do want to share it that way. But that's the main advantage. I mean, running on a Westgrid server, you definitely have a ton more resources at your disposal. But here, your namespace is isolated. Your username is your processes are just your processes. Okay, now we type the contact email web address. I will bring that up right now. And I'll type that out for you. So I'm just typing out the contact information in the chat right now. And let me put in the URL for the ORCA web page as well. Let's see. So Philip, these are not running via a batch scheduler. They are just running as isolated containers. So they're interactive containers by default. There's no scheduler associated with it. And we have them configured in a swarm right now. So when it's possible, we will actually have them move containers around depending on the load on a particular ORCA server. But right now, we don't have that sort of load, but it's definitely something on our horizon. Human clinical genomics guidelines. I'm not the person to talk to about human clinical genomics guidelines, unfortunately. You would have to go through Diane Miller, who will know definitely a lot more about the guidelines. Okay. So let's go back to the, here we go. Ooh, sorry about that. I should probably just run something in the background while we're talking. For example, let's run a sample FASTQ file. Oops. Just FastQC. What's the file name? I'm just going to keep that running in the background. Is there any way to get more than one core and 64 gigs of RAM? Yes, we are definitely opening that up, but at the same time, we don't have that much in terms of resources on these servers. These servers are show you what's on the background. These servers have probably about 32 cores each and 128 gigs of RAM each. So we've set the maximum to about half that, just in case there's something left for other people. Yeah. Okay, that was a lot quicker than I thought. Good. Then, of course, you can so could you then put 32 containers each with 64 gigs of RAM with 128 available? That is correct. It is. If you do that, the compute nodes will run out of memory, yes. Yeah. There is a little bit of oversubscription at this point, but it's just normal. But when you do run out of memory, you do run out of memory. Unfortunately, it's very possible that someone might run a 64 gig job on a very highly loaded container server. And yes, it's a sad fact of a shared system. So why not restrict it 4 gigabytes per node? Yes. We wanted people the capability of running more than 4 gigabytes, running with more than 4 gigabytes of RAM, rather than limited to 4 gigs only in terms of stability. So it's just basically what our priorities were. We wanted to give people more capabilities of using more memory rather than just limiting to 4 gigs. That's it. But at the same time, it's at the cost of potential stability. Right. Can your platform be mirrored? Mauricio, can you clarify that question? By mirrored, you mean can we have multiple of these servers, or can you spin one up in your own location? You would like to reproduce what we created. Yes. Right now, we can provide guidance on how to set one up, but it's not going to be specifically ORCA. It's going to be your separate Linux brew install with Homebrew-Science. It's straightforward right now. You just use Homebrew-Science with Linux brew. Yes. Then contact me, and I will make sure that all the dots are, all the lines are signed and everything. I will need to talk to our project managers first, though. But yes, I will definitely be able to help you out. Can we deploy your ORCA Docker on our own servers? In terms of the platform, we don't have a way to do that right now, aside from handing you the Docker images, which I don't know off the top of my head if I'm able to provide that to people, but I mean, for me, it's just a file that has a container on it. I will check with the project managers if it's possible to do. Yeah. Well, that FASTQ thing completed very quickly. Let's see if we can run a BW index on something. Oh, that was quick. Let's try some alignment then. All right. Does anyone have more questions about this? Be happy to answer any questions. So if there are no more questions, then I will, let's see. I'll just bring up the office hours for next week. Or you can watch a system administrator try to, type bioinformatics tools commands and hopefully not fail too miserably. Okay, let me bring up the slideshow again. So there are defined office hours for this on December 8th, 2 to 2:30 p.m. And you have more information at westgrid.ca/training. On top of all this, I just would like to acknowledge the work that was done on this. It's not a system I created. It was created by one of our analysts who's unfortunately not working with us now, Rudy Zhu. And of course, the greater Westgrid community and Compute Canada for making this possible.